All right, guys, back here for the second half of chapter 6, talking about appliance installation planning. I'm going to get right into it so we can get this done with. It's going to be appliance installation planning once again, and let's start over. Heat distribution. Checking room size, openings, and airflow can help establish realistic owner expectations. Careful consideration must be given to whether proper airflow and heat distribution are possible. Traffic patterns. Try to avoid placing the appliance in the line of heavily used passageways to minimize accidental contact with the appliance. Heavy traffic areas or areas close to doors that open and close often can cause safety vacuum sensors to trip unexpectedly, and proper balancing may be impossible. Guys. Get back to that one, guys. Sorry about that. All right, we're getting back to it, guys. Sorry about that. Computer's running a little slow. All right, so back to installation planning. We'll go to the next page here. I apologize, got disconnected for a second. So we're talking about appliance installation planning more. During the sales and planning process, a good deal of information has to be gathered in order to end up with a hearth system that is appropriate for the customer's needs and desires. Some of that information can be obtained in conversation, while some of it may require viewing of the building, plans, and or site visit. An important area of information, one that is not always easy to get, is the customer's reason for their purchase. The range of purposes can be broad and fuzzy, but they generally include reaction, ambiance, fun, the atmosphere, romance, tradition, design, enhancement of the hearth, zone heating, a limited area, usually remote from the main living area, or an addition that has inadequate heat, primary heat source for economy, comfort, lifestyle choice, and other reasons. Backup emergency heating for power outages, either limited area or the ability to furnish primary heat where desired. So again, it's really important to notate why these guys are installing what they're installing or why they're wanting to install. Really feel like that's super important when we talk about the planning of the installation. Every time I'm with a client, I always want to ask these questions of why. Why are you wanting the fireplace? What's the purpose of the fireplace? What's its, what's it going to do? And then of course, what the decor around it's going to be. All those questions are really important as a seller. Most retailers find it important to not only try to match customers' purpose with appliance choice, but also to use the sales and planning period to help establish realistic expectations. Expectations are everything too when we're talking about fireplaces and planning for them. I mean, you have to know what their expectation are for this area, for where the fireplace is going to be, how it's going to be set out, what it's going to do. So, we want to make sure we're really clear with that. Customers who are pleasantly surprised by their hearth system, the system will be installed for new construction. The planning details may involve timing and working with other contractors. The choice of appliance may be wider for new construction than an existing home remodel. For existing homes, an existing chimney or hearth may have to be evaluated for use with a new appliance. Find that to be true. Easiest installs are always going to be on new homes, new builds, new styles, whereas your remodels are going to take a lot more time, a lot more attention to detail because it's already a livable area. So there's more chance of error, more chance of things getting in the way. So we want to be really, really clear when we're, you know, planning for this appliance. Appliance location reflects the objectives and preferences of the homeowner for ease of monitoring and refueling, as well as for the aesthetic enjoyment. Appliances are ideally placed in frequently used areas such as the living room, family room, or den. Installation planning details include making sure clearances can be met or exceeded. Minimum clearance between the firebox and framing, papered sheetrock, and other combustibles must be maintained. So yeah, man, wherever these individuals be planning to put the fireplace, it's super important that you're understanding where they're going with it and how it relates to the clearances, to the rules of the game. A lot of times I also find too, like, how far is it going to bump out in the room, what's going to go in front of the fireplace, are they having a hearth extension that's going to go out in front, how high is it going to go. All these are really important when it comes down to your clearances and meeting the manufacturer's codes and specifications. The same is true for the area surrounding the chimney and for its penetration of walls, ceilings, floors, and roofs. The fireplace should also be located so that the appropriate minimum clearances between the fireplace and adjacent walls and other combustibles such as drapes and furniture will be maintained. Consult the manufacturer's instructions for the specification. This spacing is required to prevent hazardous overheating of combustible materials by heat radiated from the fireplace opening. Man, we always keep coming back to this, no matter what it is, but we're talking about, the clearances to combustibles, and, it gets really, really boring, but it's super important to notate that no matter in what stage of planning we're in, we're seeing that those factors keep on coming into play. Like, how far is it from the adjacent wall? When you're doing corner installations, you'll see that, oh, well, it's not only about having the proper framing, but it's also about having the proper clearances from right to left, whatever walls to the left and to the right of them. So, what furniture is going to go out in front of them, as there oil painting above. All this is super important when we talk about installing and planning for the appliance. Should be something that you notate everywhere you go, even after the fact. You see something that's not right, and man, I just don't think that's right after all the training I've done. Speak up, say something. It's good to ask the questions. It's good to question, what you see when it regards safety. Some manufacturers offer shielding accessories or recommend materials that allow their fireplace to be installed at reduced clearances. These reduced clearances are normally included in the manufacturer's instructions for any requirements for the minimum size of the room where the fireplace is to be located. The fireplace should not be located near frequently open doors, central heat furnace outlet registers, or cold air returns, or in any area where turbulence or negative pressure effects will create an air movement that will cause smoke spillage or allow flames, sparks, or ashes to escape the fireplace opening. Do not place the fireplace directly across from or in an area where the heat output will affect central heating thermostats. Pretty self-explanatory there. Again, this is in regards to where the location is, to airflow, to where we see thermostats, things like that. That's really, really important that we're looking at. It's important for both safety and comfort that the freestanding stoves be sized properly to heat the intended space. If an appliance is much too large, it cannot be operated in its optimum burn range in any but the coldest weather conditions. Oversized solid fuel appliances are particularly problematic when operated for the majority of the heating session in a slow burn, air-starved, and creosote-producing fashion. EPA appliance design alleviates the problem of oversizing somewhat but sensible sizing, including taking into account factors such as climate and intended use, heating objectives, and house insulation tightness, and user understanding of adjusting fuel loads to weather conditions are still important factors. So we're talking about freestanding stoves, and we'll delve in a little bit deeper as we go into this. customers and for milder climates where operation so at low burn rates is expected, it may be worth considering appliances with a wider range of turndown rates that deliver effective burns. Lack of attention to these factors may result in lower combustion efficiencies, greater emissions, higher rates of creosote and moisture accumulation, and customer dissatisfaction. It is generally preferable to err by under rather than oversizing an appliance. Occasionally, if appliance is significantly undersized, however, overfire heat conditions may cause premature failure of the appliance. Discoloration of the finish, warpage, or cracking with an appliance is indicators of overfiring. Stove location. Clear system combustibles are often the first consideration when planning freestanding stove installation. Walls and floors, mantle and trim, and furniture are some of the combustibles that must be taken into consideration. Floor protection, both size and materials, are important considerations. Traffic patterns in the room may also need to be taken into consideration, particularly for freestanding stoves. If the objective is to heat more than the room in which the appliance is located, centrally located stoves usually heat the greatest area of the home with the greatest comfort. So obviously with these stoves, they're very much more intentional about what they're doing. So, we're still paying attention to some of the things that we did with the other ones, but these also take into consideration, um, wherever we're working to the objective is being more heat or it's going to be decorative in nature. These are all things that are going to be taken into consideration for the stove location. Size of the room and heat distribution factors such as doorways, stairwells, and forced air distribution may also be considered. The location of the central heating thermostat can be a factor worth considering. Some considerations that affect operation and maintenance that may affect installation planning include appliance features such as loading door location, ash removal systems, ease of performing, maintenance activities, space for safe convenience fuel storage, wood or pellets. The location selected should require minimal cutting of joists and rafters and limited alteration in the dwelling structure. Precise sizing and unrealistic given the precise sizing is unrealistic given the variables for fuel for wood burning, climate, weather, home construction, and user desires and skills. Nonetheless, understanding the sizing considerations includes prevent avoidable errors. Manufacturer supply guidelines may be a source for misunderstanding. The numbers, usually in square feet or number of rooms, are subject to broad interpretation. The numbers may be confusing or inaccurate if assumptions are made about ceiling height, varying home insulation, and weatherization factors, climate comfort level, and customer expectations. Disparity between manufacturer recommendations for similar size and BTU output units is a source of confusion for customers that often needs explaining. So with these units, there's so many variables that it's important that a professional or someone that is professional are helping within this planning process. This is where we use and leverage our knowledge. This is where we use and leverage what we have to offer the end user, the public, people around us, because we know how to interpret these things and how to work through them. So it is saying a lot of this, even for us, can be points of confusion because you're hearing so many different things from the manufacturer to the municipality to people around you who've been trained. I mean, these are all factors in how the planning goes about. Sorry about that, guys. Confusing numbers and variables mean that clear communication with prospective stove owners is essential. Factors that may need to be explained and discussed include there are to be heated in cubic feet, insulation values in ceiling walls and floors, air infiltration, what is the age of the home and condition of the structure, is it tight with good weather stripping, window size, quantity, condition, and location. If numerous large windows and or patio doors are present, exceeding 15% of wall space, heat loss may be significant. Double or triple glazed windows combat some of this heat loss. Exposure to northerly directions may mean great heat loss. The space configuration of the structure, is it open or partitioned off into many small rooms? Are areas separated from appliance by barriers, great distances, or turns that prevent airflow? Are there non-standard above 8 feet ceilings? If so, are there low-speed ceiling fans? Customer expectation i- is the appliance to be primary, secondary, or recreational heat source? How does the customer describe comfortable heating levels? So, I mean, just such a deep breadth of information to kind of take when you're talking about these stoves because there's so many variables. I mean, just looking at this makes my head turn. Just thinking, man, is it really necessary to ask all these questions to consumers? And my answer is always yes. Yes, it is. If you're trying to get the easiest installation, the most straightforward expectations from your customers, then you have to ask these questions. You have to consider the variables. I can't say it enough. There are tons of variables out there. You want to begin to train and learn all of them with each unit that you're learning, whether freestanding stove, whether zero clearance direct vent, whether wood burning, whatever it is, you want to know everything. BTU ratings, where the number came from. Efficiency. The EPA numbers do not represent testing of each model and brand. Instead, the hand tag efficiency rating is a generic default efficiency for the type of combustion system. 72% for catalytic appliances and 63% for non-catalytic. Some manufacturers have had their appliances tested for efficiency by independent testing laboratories. Under current NSPS proposals, all EPA certified appliances will undergo standardized efficiency testing. Heat output. The high heat output range on EPA on EP on the EPA hang tag has been a measure of BTU produced from a single load of fuel with the appliance air control set at the maximum level. It is important to understand that the appliance was not reloaded during this test and the test continued until fire burns down a specified amount of coals. The total number of BTUs produced during this burn time were divided by the length of time of the burn to calculate the high heat output. This test protocol resulted in confusing numbers. An appliance with a much larger firebox might have an EPA high output rating lower than a smaller appliance. Maximum BTU output differs from the high BTU output. Maximum heat output is a measure of the highest amount of heat that can be safely generated on a sustained basis. Appliances tested by manufacturers for maximum heat output are typically reloaded frequently, simulating the homeowner's operation to produce a considerable amount of heat. Again, testing methods have not been standardized and have varied from manufacturer, which may change with time and NSPS requirements. Fireplace inserts. Placement is usually predetermined by the location of existing fireplace. Planning the insert installation is therefore a process of making sure that the fireplace is appropriate for an insert and that the insert fits properly in the opening, meets clearances to combustibles, has adequate floor protection, proper power supply, and reasonable maintenance considerations. So inserts, we get this all the time. Most confusing thing, gas logs versus inserts. Inserts obviously are for existing fireplaces, but they will be piped as well. So it won't just be a log set. You're going to have a whole system going in there. The fireplace should be checked carefully to verify its appropriateness for a pellet insert. Minimum fireplace dimensions should be reviewed carefully, particularly with factory-built fireplaces, which may require larger dimensions than for masonry fireplaces. Check width and height of the opening first to be sure that it's large enough to accommodate the unit. Then check these dimensions again to be sure that the insert surrounding panel will cover the gap between the unit and the face brick, according to manufacturer's instructions. If there are stepped out brick or protruding materials such as stone on the face, the fireplace make sure panel will fit and seal properly. Factory-built fireplaces, also known as zero-clearance fireboxes, fireplace should be checked for proper installation according to manufacturer's instructions. Extreme caution should be taken regarding the face of the fireplace, openings or vents on the front of some fireplaces bring in air to cool the firebox and or chimney. That is essential for safe and minimum clearances. These openings must not be blocked by the insert panels. Instructions for installation of a factory-built fireplace typically include language for a label that must be attached to the fireplace indicating that it has been altered to accommodate a fireplace insert and should be inspected before reuse as a fireplace. The second area of concern regards the safety listing when installing a wood-burning fireplace insert in a factory-built fireplace. NFPA 211 prohibits a solid fuel burning appliance using the flue of a factory-built fireplace unless it's specifically listed for such installation. It specifies that a fireplace insert or heat exchanger installed using an existing flue service serving a factory-built fireplace be listed to use with a specific model factory-built fireplace. It is advisable to consult with manufacturers of the factory-built fireplace, the fireplace insert, and the authority having jurisdiction concerning an acceptable safety listing. Some manufacturers require or recommended full relining for pellet inserts installed in a factory-built fireplace. Sorry about that again. So I'm gathering with these inserts, it's really, really important not just to put something into an enclosure, but to look at the different specifications from the manufacturer on the new one and including the old one if you're dealing with the factory built. Um, you know, seeing those codes, seeing the standards, seeing what it can handle from heat to clearance to everything is going to be really important when we talk about putting an insert into an existing fireplace. It is helpful to note whether the fireplace floor drops down from the hearth extension. In some cases, a combustible shim must be used because the appliance does not have leveling bolts. Irregular hearth extensions, materials such as stone should also be noted. Close attention should be paid to the fireplace throat to plan a properly sealed block off or make sure that the surrounding panel is sealed. If required, according to manufacturer's instructions to prevent the chimney from becoming a source of makeup, air, and a tie at home. The fireplace and chimney should be thoroughly cleaned to avoid materials being blown into the house by convection blower. A number of manufacturers recommend painting the interior of the fireplace to seal off soot completely. So this is a fireplace dimensions and conditions. Do not place chimney terminations under overhanging trees or obstructions. Do not place in a location that requires substantial alterations to house structure, especially avoid cutting roof rafters. Attic installation shield not shown, but is required. Just a whole bunch of stuff you want to look at when we talk about this. Natural draft chimney location. Natural draft chimney should be located so that it is as vertical as possible for maximum draft and cost reduction. An interior location offers better draft performance than an exterior chimney location due to reduced heat loss from the chimney. The chimney should not terminate under overhanging trees or other obstructions that might create air turbulence that could reduce draft. The location selected should require minimal cutting of joists and rafters and limit alteration of the dwelling structure. Customer Customers understandably focus on the appliance and usually actively participate in decisions about its type, style, size, and location. The same is usually not true about the venting system. Other than a concern about the appearance and cost, most customers regard the chimney as about as interesting as the tires on their new car. These circumstances and the crucial importance for heart system performance and safety increase the responsibility of the hearth planner and installer to make sure that the details of the venting system that we examine here are carefully planned and carried out. Venting system problems are too difficult and expensive not to make a strong effort at preventing, planning, and education of customers. Stopping point, super important that we talk about venting. Venting is such an important and inevitable factor when we talk about fireplaces. You have to have it. There's no getting around it. You need vent pipe, but you also need to understand how vent pipe works, how it adapts, how it curves, how it drafts, flows. All of that is super important when we talk about the sizing and the requirements. You cannot install a fireplace without understanding the most basic of premises when we talk about vent pipe. So again, you have question on vent pipe, the different type, what kind we use, what sizes there are, You need to ask somebody. Ask me, ask my dad. I'm more than willing to answer questions because one of these days you're going to come across that and you're going to need to know, hey, how does this work? And that's the most important thing to me. Natural draft venting systems, just kind of showing good draft and what that looks like. Here's exterior location, talking about spillage. Different stuff we look at here, pretty interesting. So natural draft venting systems, chimney location. Obviously, appliance location normally dictates chimney location, but there are good reasons to make chimney location at first consideration. During the planning stage, these important venting location and practices should be followed whenever possible optimum natural draft and system performance. Install appliance and chimneys inside the building envelope, heated portion of the house. This practice is extremely important in keeping flue gases as warm as possible for good draft and to prevent cold hearth syndrome when the system is at standby. Locating fireplaces and outside chases is considered the main cause of complaints about fireplaces that spill odors and cold air when not in use, and that smoke when a fire is lit. Design the chimney to penetrate the building envelope at or near its highest level. The chimney should be as taller than the highest part of the building envelope in order to overcome the negative pressure that results from house stack effect. The practicalities of roof design usually make following this practice another reason for an interior wall location for the appliance and the chimney. If the appliance is on an exterior wall, having the chimney exceed the highest part of the heated building envelope means a very tall, hard to stabilize, unattractive chimney exposure above the roof. It also means that a large portion of the chimney is exposed to cold temperatures. Locate the chimney top above areas of wind turbulence. Another height consideration that affects chimney location is wind turbulence. The height and proximity of adjacent roof, other structures, and trees should be taken into account in selecting appliance and chimney location. Again, location on an exterior wall can result in another condition adverse to draft and performance. Chimneys low on the roof line are more prone to the effects of wind turbulence than an essentially located chimney near the roof peak. Chimney should always be supported above the roof according to the requirements in the chimney installation instructions. This requirement set the maximum air leakage rates. This requirement sets the maximum air leakage based on climate regions of the country. For zones 1 and 2, the southernmost parts of this of most of the blah, blah, the southernmost parts of some southern and on western states at an air leakage rate not exceeding 5 ACH50. For zones 3 through 8, the rest of the country, the rate must not exceed 3 ACH50. As the 2012 edition of the IRC is adopted over time, the impact of energy efficiency requirements on residential construction and related industry become apparent. Those requirements include increased insulation, better windows, tighter ductwork, and tighter construction. The tighter construction will revolve around the change from vocabulary 7 ACH50 to mandatory verifiable maximum 3 ACH50 for new homes in most regions of the United States that have not had such energy efficient requirements. In order to achieve such low air leakage rates, new construction will focus on the air barrier for the home. Air barrier products include house wraps that function as air and moisture barriers, closed cell spray, polyurethane foam, and board stock, such as plywood or oriented strand board, and extruded polystyrene. This will mean that not only hearth products that require outdoor air for combustion will be a concern in very tight residential construction, but also hearth systems that penetrates the air barrier will impact the leakage rate of the home. Interesting stuff there, guys. Interesting stuff. For hearth appliance, the first concern may be ensuring installation in space that provides the required volume to ensure adequate combustion air. That may be difficult given the provisions in IRC and NFPA 211 that either reference to the appliance manufacturing instructions or call for adequate combustion air. This may mean that it will be necessary to consult with manufacturer regarding installation recommendation in tight constructions, including instructions for any sealing of the vent system penetrations of the air barrier. The concern for spillage in a negative pressure environment may rule out open chamber hearth appliances. Finally, construction of a chase must be concerned with maximum air tightness. That may include extending the air barrier around the outside walls of the chase and sealing any penetrations such as vent termination or outside air kit according to instructions. Drywall with tape or an equivalent method for the interior, as well as sealing of the perimeter of the fireplace or the surrounding wall according to the manufacturer's instructions. Local code must be followed in the process. That is the conclusion, guys. Appreciate you guys watching, and we look forward to meeting with you guys next week.